Quick example of interconnection. So in this case, what we're interested in is the difference between two quadratics, and whether the difference between two quadratics itself forms a parabola, that is, whether it's a quadratic function too. So this is equivalent to closure under addition and subtraction, and I think it shows really some of the really nice strengths of how these systems work together. So here you can see I've set up this GeoGebra window that shows the two quadratics and has a line that shows the difference between them. Down here, the length of that line is graphed, and you can see just using the tools that you get from GeoGebra on its own that thing sure looks like a parabola. It's got the right shape, right, in this case. Although, of course, you can move around these values, you can change the shape, right? You can get it to look quite different. So how do we know that it's really a parabola? And there's going to be a parabola no matter how we manipulate these variables. That's the kind of thing that we get specially, it's one kind of thing that we get specially from algebra. And sure enough, what we can do is take down here the difference between the two, which of course you could produce using other systems, but in our system you get a special insight into it, right? You can produce that difference between the two. And you can see that sure enough, once we simplify that difference down, we get something that has the form of a quadratic, right? That's just what we mean by a quadratic, and that's a proof in numbers, right? And moreover, with this term tracing feature I've been talking about already, you can really understand where that comes from, right? So you can see that each of these quadratics is going in and making up the new one. And they're doing it point by point, moreover. So the coefficient of the squared term becomes the squared term, as does the coefficient of the squared term of the second quadratic. In the linear term, again, you're combining the linear term from one, the linear term from the other. In the constant term, it's the constant term from one, the constant term from the other. And that's the other thing you get from algebra, which is insight into the structural reasons why a thing happens. Why is the difference between two quadratics quadratic? Well, because we can combine coefficient by coefficient for each of the terms, right? And that gets us into a larger insight. If you want to, you can also, of course, make this thoroughly symbolic. So now you can see that exactly the same thing is going on with two generically defined quadratics. We can see, right, that we get the b's going together, that is the coefficients of the linear term going together. We get the coefficients of the squared terms going together. And we can see the whole thing follows exactly the same sort of overall visual pattern, where the quadratic breaks up into each of these components, the quadratic breaks up into each of these components, right? And we get the same overall pattern here, where the quadratic breaks up into each of the components. So that's the kind of visual benefit we get from this term tracing, and the kind of insight benefit we get from putting GeoGebra and Graspable math together.